Okay, we look at our third video on the series. They said that Kofi rides his bicycle at 5 meters per second along a straight road for 25 minutes. He then dismounts and pushes the bicycle for 5 minutes at 1.7 meters per second. Now they are saying that we should draw a distance time graph and find the average speed for the whole journey. And so we have here is in minutes, but our speed of Kofi is given in seconds, so we just simply have to convert those minutes to seconds. Okay. We need to know the distance for this particular speed too. Okay. We know that average speed is equals to distance over time, and so which implies that distance is equals to the average speed times the time. So if we are taking the first part of the journey, which is this and this one is actually equivalent to 25 times 60, and then 25 times 60, you are getting 1500. So 1500 seconds for that part, 1500, and so that is the seconds. So we just multiply these two things. We have 5 times 1500, and so you get something like 7500 meters, which is just equivalent to maybe equivalent to 7.5 kilometers. Yeah, 7.5 kilometers also. Yeah, 7.5 kilometers. So we have something over there like that. That's for the first part. That's the distance for the first part. So now distance for the second part, it was 5 minutes. So this 5 minutes, you have to convert it. So 5 minutes into seconds, that's just 5 times 60, which is just 300. And so the distance, so this, we can call this d1. Now our d2 is equals to the average speed for that part, which is 1.7 times 300. So we have 1.7 times 300, which is 510 meters. You see. So now we now want to find the average speed for the whole journey. So let's see average speed for the whole journey. So let me write total average speed is equals to, so the total distance, which is the 7500 plus 510 all over the total time. Total time is 1500 plus 300, and this thing you get 7500 plus 510 all over 1500 plus 300, and so you are getting something like 4 whole number 9 over 20 meters per second. That's the average speed for the total journey. But they are saying that we should draw a graph, distance time graph. So we just draw a graph like this. Here is your distance, and this is the time. Here is 0. So for this part, I can just indicate that, oh, this distance I think is 750. So 750, and then So let me just put something here to indicate that this is 750. Maybe 1005. So this is the first point. So it's just a straight line like this up to this point. Then after here, so I can just say here's 1500. This is the time, and this distance is 7500. So we add 210 to 8, 510 to 8. So adding 510 to 7500, you get 8010. So let me just indicate somewhere here, and maybe indicate somewhere here by adding some 300 units to it. And so maybe we'll get to this point or so. So you get another line from this point like this. Maybe something like this. But our interest is on this line, this line here. So that is our graph, and you indicate the time here 8010 like that, and you are good to go. So this is our graph that they said we should draw to. That's a distance time graph. It's just a straight line that is going up from the origin. That is all. Now we look at question 6, saying that a particle starts from the point this point here with a velocity of this. You're saying that we should find the equation of the line along which the particle moves. Well, r is equals to r naught plus vt. This is the formula for finding the equation of a line or any particle, and r naught is representing the initial point, and v is the directional vector. In other case, this velocity that has a direction, and r is what is giving us our equation. And so we just have to plug in these values to get our equation. So we have r to be equals to the first point, which we can write as a vector, that's 247 plus t. Then the v is what, 3 2 negative 8. So that is all. This is the equation of the line that they are looking for. We can also simplify it further or something if we want, but we can also leave it this way. Simplifying it further will mean that we just have this one, r to be equals to 2 plus 3t 4 plus 2t, and then 7 minus 8t. So we can have something like this, or we just leave it. So, and this one, we can write it in symmetric form or in parametric form or something, just like that. And so this becomes the equation of the line that they are looking for. So I'm going to stop here, and then we continue from the next question.